Hi, today I will tell you nothing new, possibly. In my last 6 videos, I explained you how to do edgeR protocol in 5 different ways. And I also decided to briefly summarize all this information once again. Pay attention that edgeR is pretty major protocol for bulk RNA-seq analysis, although DSEQ2 is also popular and we will come to it. What we do with these protocols, we mostly rely on downloaded files. We deal with the downloaded file formats. We still use getGeo function to fetch relevant information about samples. It's probably the best way to do it. Sometimes you will see a button GeoToR for RNAseq data, but this is all about DSEQ2 protocol, not edgeR. edgeR is not operating online. If you prepare RNAseq data by yourself, then you will probably use Illumina sequencing platform, which makes short reads, and short reads are okay for RNA-seq analysis. Note that you count expression by reads per transcript, and therefore the read length should not be too long. It's to the contrary, it should be short enough to be economic and efficient. Then again, if it is your own data, you have to check the quality of the sequencing by using FastQC, MultiQC programs. It is an important step, and later on, after mapping, this information will be not available for you or for others. The mapping is usually done by star, although if you read edgeR user's guide, in chapter 2.2 you will see this information that authors like subread feature counts pipeline, whatever it is. Then they also mention star. Then they also mention bowtie top hat HT-seq as if it is a one single alignment tool, but it is not. Pay attention that top hat and bowtie are two different alignment tools. Bowtie is made for aligning short DNA sequence reads to a reference genome. It's not doing any splicing analysis, whereas top hat is made splice aware, so comparable to a star alignment, and curiously enough it's done in a Cole Trapnell lab, who is known for single cell RNA-seq analysis. And HT-seq is something completely different, which processes reads aligned with the high stat or star, so it is a secondary to the mapping with some extra options which we don't have to discuss here. All this information is available on bioinformaticshome.com. And what is not yet mentioned here is a Salmon, this one, which is quite popular for mapping against transcriptome, not against the genome, and therefore if you're interested in transcript isoforms, I see that Salmon might be more useful than star, for instance. When star makes the files, you usually use the tab files for making the data table and going further with the gene expression, but do not forget that there are also BAM files generated which contain SNP information, in general sequence polymorphism, which can be retrieved at any moment and used if you're interested in it. Now back to the edgeR scripts itself. Curiously enough, some edgeR scripts are sitting in a Lima tutorial. Okay, what is Lima? Lima is acronym for linear models and differential expression, as well as edgeR is an acronym for empirical analysis of digital gene expression. Very nice. Anyway, 2 scripts out of 5 are sitting in Lima, and the other 3 are in a edgeR user's guide. To make it even more obvious, I compiled this table. I also numbered all those scripts which I showed you and called them briefly lemma trend and lemma wom. It's exactly as authors in lemma tutorial recommend to name them. The application for this script is not specified and it feels a little bit obsolete. By the way, it can be used if your data are good, but very often data are not perfect. There are some outliers, some other problems, and all the efforts of the authors of edgeR were directed to compensate for these troubles, for outliers, for some noisy data, for something else. And therefore, whenever you think what to choose, you can always choose the latest version, which are more resistant to all kind of troubles. And Quick Start Classic GLM is generally recommended, although lemma wom is alternative option to deal with the problematic data. Classic edgeR is very limited because it uses only one factor design, and alternative GLM is slightly different from Quick Start. One is using likelihood statistics, and a Quick Start Classic GLM is based on quasi-likelihood methods. And if you are not in statistics, then you simply have to remember that the underlying algorithms are somewhat different. Yeah, and if you go into some papers, you can also find some funny name glimmer between lemma and edgeR. Is it the third package about the same? No, it isn't. It is a graphic enhancement for your protocols, to which I will come later as well, which makes MDS, MA plot and volcano plot nicer than otherwise you would do it in a basic R environment. So why I'm talking so much about lemma while talking about edgeR is because lemma is the beginning of this chain of the scripts, and it is a basis for edgeR, which was also to some degree inherited by DSEC protocol, although written by totally different group of statisticians and programmers. What is common to all edgeR protocols is what is not in the core of the analysis. I don't mention that you have to import the data and sample information. It's kind of an obvious. Then, of course, all protocols include a filtering step to remove lower expression. There is no point of keeping them, and even more, it is dangerous to keep them around, because after normalization data are converted in log CPMs, counts per millions, and log of small data become negative and very big negative values, which might be confusing and misleading, and therefore it must be filtered off to prevent this problem as well. And then the end point is dispersion analysis, basically the core of the business, and from dispersion calculating p-values, meaning what's more likely, what is less likely, what is significant and what is not. And then what is different in all edgeR protocols is in one case possibilities for factors in the models, how you define what you compare to what, and how you do a dispersion analysis, because defining groups and factors also influence how the dispersion is analyzed. Then details of the dispersion plot are confusingly different. Different scales, different transformations. Pay attention to it and do not mix up. And at the end, the likelihood statistics different by itself. and also differs because the dispersion analysis is done differently. And for simplicity, I also copied all the scripts to my GitHub page. I am not fluent with GitHub pages. I do my best, but it's still difficult. But generally, if you know my name, that's me. I opened the group R for beginners. Within this R for beginners, I have a directory or branch, better say, edgeR scripts, where I placed all edgeR scripts numbered the same way as I showed you in a table. I mean this table. So those 1, 2, 3, 4, 5 are compatible with my GitHub. I hope this information is useful and you will be able to find the page. If you could not make it from the screen, now you can find my GitHub and download the script and go slowly through and make your modifications. And here I will probably stop discussing edgeR protocols.